Hey guys, welcome to my channel. This is solving system of inequalities through graphing, and in this video I'm going to show you how to solve a system of inequalities through graphing, right? And on the right side I have written a CFS. CFS stands for criteria for success, and pretty much if you follow these steps you should be able to do a problem like this in less than 5 minutes. Pretty simple. So first thing that I'm looking for is for a set of points, and notice that I say points. In a system of inequalities, I'm going to have multiple points that make both of these inequalities true. And to do that, I'm going to graph. And the first thing that I'm going to do is I'm going to plot the y-intercept for my first equation. The y-intercept for my first equation is -2, so I'm going to plot it here. So I'm going to check that. My second step is to apply the slope. My slope is -1. Every time I have a minus in front of a variable, that means a -1. So because my slope is negative, I'm going to use either one of these combinations. I can either go up left or I can go down right. So I'm going to go one up, one left, one up, one left, one up, one left. And I can also go one down, one right, one down, one right. After I apply the correct slope, I'm going to use the correct line. And I drew this picture here to remind ourselves which is the correct line that we can use. If we have greater than or less than, we're going to use a dashed line, okay? If our inequalities is greater than or equal to or less than or equal to, then we use a solid line. In this case, I have greater than, and therefore I'm going to use a dashed line for my first inequality. So I'm going to do that. So far, I have already graphed this, but there's one more thing that I'm missing. It says shading. Now, because I'm looking for all the values of y that are greater than -x minus 2, I'm going to shade up. Okay. And now I'm going to repeat the steps above for my second inequality, which is y is less than -5x plus 2. Okay. For that, I'm going to use a different color. And I'm going to go a little bit faster. Again, first step is I plot the y-intercept. My y-intercept is +2, so I go to 1, 2. I'm going to plot that one. And then I'm going to apply the slope. My slope is -5. And again, I wrote the combinations that you can use here. I'm going to write down a 1 on the bottom on the denominator. And this tells me the amount of units that I'm going to move to the sides. So in this case, I'll move 5 units down, 1, 2, 3, 4, 5, and then 1 right. And that's pretty much the only point that I can graph here. After I have applied the slope, I only have 2 points in this case. I'm going to draw the line. And one more time, I find myself with y being less than. Because it's less than, I'm going to do a dashed line. So let's do that right now. This is not a very good line. It's actually pretty crooked, but it'll work. And after that, I'm going to shade. So let's think about this. I'm looking for all the values of y that are less than, because it says less than, I'm going to shade down below the line. So it will go this way. Now, you might think that you're done with everything, but the most important part is to understand what happened here. And the solutions for this system of inequalities will be found where both shadings overlap, And if you can see here on the video, the place where the shadings overlap is right here in the middle. So what that means is that any point that I pick that falls into this overlap shading will make this system of inequalities true. I'll give you one example. 1, 2 will be one of the points that makes both inequalities true because it falls where the shading is overlapped. On the other hand, 2, 1, it is not part of my solution set. It is not part of my solution set because it falls outside of the where the shading overlaps. So I hope this helps. I'm going to record another video on a problem that is slightly more complicated than this. But if you follow these steps, you should be able to solve this system of inequalities.